Hello students, welcome to this last video of a straight line series. So now we are going to study one thing which is important, slope point form. So before that I would address a question which students have raised after seeing the previous video. So there was a confusion among students that when I was telling them that if I want to find the equation of a line which is parallel to y-axis, in that situation I told that y is equal to mx plus c can be written as y by m is equal to x plus c by m, and then I told them that m is equal to 90 degree. In such situation m is equal to undefined, tan 90 undefined, and in that situation what we did was this becomes 0 because 1 by m will be 0, this also becomes 0, so we get a line x is equal to 0 which is the y-axis. Now they said that this is coming out to be y-axis. Why are you saying that this is a line x is equal to constant some other value? It is not coming so. So basically, if you try to understand here this c, which is the intercept of this line on the y-axis, this is actually not intersecting it anywhere. It is actually intersecting at infinity. So there is a very important concept here that if you want to take c as infinity, and obviously you are taking for this line m also infinity, so infinity upon infinity equal to 0 is not a correct statement, but we took it to be 0 to give you an understanding of a line which is y-axis. Actually this may be any value, we don't know about it, so we need to simplify. So basically what happens then, from this equation, when we are trying to find the equation of this line, then you will get stuck here because c by m, the value you won't be able to calculate infinity upon infinity. So it is very easy over here that this is a line whose x coordinate is always same everywhere. So in that situation, obviously x is always constant, that is the distance from the y-axis, and the slope is obviously 90 degrees, so it is undefined, and therefore the y coordinate is varying from minus infinity to plus infinity. So the condition is not on y coordinate, but the condition is on x coordinate, that it will always maintain a constant distance from the y-axis. So its equation is x is equal to c. If a line is parallel to y-axis, 3 unit left of y-axis, then equation will be x is equal to minus 3. So it is quite easy. It is not always necessary to apply this, especially in this situation, though I told you to proceed like this, but the more correct way is to understand like this, because infinity is a very dangerous topic. We will also see this in the chapter limits and derivatives, which will help us quite easily. So now let us come to the last topic which I was telling you. If you take a point x1, y1, and a slope is also given of that line, how can you find the equation of that line? So there is a line, it is passing through x1, y1, and a slope m of this line is given. Can you find the equation of a line by taking a variable point x, y? This is a given point x1, y1. So sir, this is similarly as we did for slope intercept form. Yes. There we had slope, and by the help of intercept we got a point 0,
calculate the value of the constant c.
We calculate the value of the constant c by the help of that. So here also we can similarly apply the definition of slope, and we will say that this is equal to y minus y1 upon x minus x1. So we can say that y is equal to m into x minus x1 plus y1. This can be written as equation of a line in the point slope form. There is another form also, 2-point form.
Yeah.
We need to explain.
Yeah, that is also important. In some cases, you may need to find the equation of a straight line when 2 points are given, or coordinate of 2 points are given. Let us say we have given 2 points. One point is x1 and y1. The other point which is given is x2 and y2. So these 2 points are already given to us. So values of x1, y1, x2, y2 is known to us. Now in this case, the equation of straight line can be written as y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. So this is a general form of straight line when 2 points or the coordinate of 2 points are given to us. This is very similar to this. This value represents simply the slope of the graph.
So these 2 points are joining and you're getting the line. So this is the slope of that line.
Slope of that line.
Okay.
So this is how, if 1 point coordinate is given or if 2 points coordinate is given, we can always calculate the equation of a straight line.
So we can say that this is actually 2-point form.
2 point form here.
So if we summarize all the forms which we have studied till now, so I think we need to know two things basically. Either we know a point and a slope, or we get 2 point.
2 point. So it will be slope from there.
Yeah. And we can get a slope and an intercept.
Intercept.
Yes.
So there are three things. If we are given to us, so 3 different types of situation can arrive to us, and then we can accordingly have to apply the values there.
Okay. So let us give them a question,
Yeah.
and then we will see in the next lecture then how these concepts are getting applied to the
Various
physics.
parts of physics.
Various part of physics. So there is a question for you as we have studied in this lecture. Find the value of k such that 2 comma k minus 3 comma 1 and 5 comma 2 are collinear. I think they can try to apply this concept little bit. So if there are 3 points and they are collinear, that means they are lying on the same line. So how can you find the value of the unknown here, which is k? So we will discuss this in the next class, and this form will help you to apply this.
And in the next lecture, we will discuss application of straight line in physics as well. So thank you for this lecture, students, and we will meet in the next lecture with some different concepts of application of straight line. Thank you.